Hello students, today we are going to start with exercise 5.4. Already we have discussed about the derivative of the various functions and have taught you the way it has to be done. Now in exercise 5.4 of your NCERT, we have to deal with the derivative of various inverse functions also. Although we know that we have not done about the inverse function, that we will be doing in chapter 2. But I would like to tell you the various inverse functions which are trigonometric, basically various inverse trigonometric functions which will be sine inverse x. Raised to power minus 1 means sine inverse x, cos inverse x, tan inverse x, cot inverse x. There are six secant inverse x and cosecant inverse x. We will be dealing with the derivative of these four first. Derivative of sine inverse x, it is 1 upon under root 1 minus x square. Derivative of cos inverse x, it is minus 1 upon under root 1 minus x square. Derivative of tan inverse x, it is 1 upon 1 plus x square. Derivative of cot inverse x, it is minus 1 upon 1 plus x square. These four you need to learn so that you may understand the questions properly. I am going to start with the first question of exercise 5.4, where it says y is given equal to e raised to power x upon sin x, and we have to find the value of dy upon dx. If you remember, in your 11th standard we have done about the quotient rule. What was the quotient rule? If the function is given in the form of numerator upon denominator, then its derivative is denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator ka square. So we are going to apply this quotient rule here. That you are going to deal here. The way it has to be done: y is equal to e raised to power x upon sin x. This is numerator and denominator. So differentiating both sides with respect to x, you will get dy upon dx, which will be sin x into derivative of e raised to power x minus e raised to power x into derivative of sin x divided by sin square x, which in turn will give you sin x into e raised to power x minus e raised to power x into derivative of sin x is cos x divided by sin square x. That's the answer for the first question. Now I'm going to start with question number 5, which says y is equal to log of cos e raised to power x, and we have to find the value of dy upon dx. Now if you remember, function log x is given, then its derivative is always 1 upon x. So we will be starting with the same strategy. Derivative of log will be 1 upon whatever is the function with log. Then further derivative of this function. Y is equal to log cos e raised to power x. Differentiating both sides with respect to x, you will be getting it as dy upon dx 1 upon cos of e raised to power x into derivative of cos e raised to power x. What it will give you? 1 upon cos e raised to power x. Derivative of cos is minus sine. E raised to power x will remain same, but further derivative of e raised to power x. Hence you will get minus sine e raised to power x divided by cos e raised to power x, and derivative of e raised to power x is e raised to power x. That's the answer for this question. Fine. So based on all these definitions, the way we have been doing our quotient rule as well as product rule, you can easily complete your exercise 5.4 from your NCERT. Now I would like to discuss with you exercise 5.5. Before I start with this exercise, I would like to tell you, whenever you were finding the derivative of any function, if it was e raised to power x or maybe sine square x or maybe sine of 2x plus 3 whatsoever, you were having in exponent there was a number, constant term, right? You have found the derivative of sine raised to power 4x or cos raised to power 5x anyway. They always have the exponent as the constant number. But if you have been provided with, you have to find the derivative of sine x raised to power x. That means variable ki power variable. So whenever you have to find the derivative of any function where function is mentioned in this way, variable raised to power variable, then what you need to do first, you will be taking log on both sides. Once you take the log on both sides, then you differentiate. For example, I'm picking up this question only. Y is equal to sine x raised to power x. Here I'll say taking log on both sides. You will get log of y log of sine x raised to power x. Before I proceed with the question, I would like to tell you, if you have been provided with log of x raised to power a, then this exponent will come here. It will become a into log x. Then log a into log a into b. This will be log a plus log b. Log a upon b, this will be log a minus log b. These are very brief logs which I am telling you, because these much you will be needing in the questions. Again I repeat, log x raised to power a, it will be a log x. Log of a into b, it will be log a plus log b. Log of a upon b will be log a minus log b. And this is applicable if in place of constant we have the variables, then also it is applicable. So we are going to use same here. Log y will remain log y, but this exponent x will come down. It will become x into log sine x. Now you will be writing differentiating both sides with respect to x. Derivative of log y will become 1 upon y, and derivative of y will be dy upon dx. Since here are two functions, x and log sine x, first function, second function, and there is dot in between, that is for product. So we are going to apply product rule here. X into derivative of log of sine x, then plus log of sine x into derivative of x, which will be 1. Now derivative of log of sine x, log ka derivative, it is 1 upon, so it will become 1 upon sine x. Further derivative of sine x will become cos x. Hence you will get 1 upon y dy upon dx, x 1 upon sine x into cos x plus log of sine x. And in the last step, this y we will be shifting here, it will reach here, and from here it will be removed, and this value of y you will be substituting whatever was the original value of y that you will write here, and that's the complete answer for the question. Fine. On the basis of this, I would like to start first question of your exercise 5.5. What does this question says? You have been provided the function cos x into cos 2x into cos 3x, and you have to find the derivative of y with respect to x. Now we know very well all these three functions are given in the product form. If I start applying the product formula, then it will be difficult for me, because then I have to consider this as the first function and these two as a second function. When I come to find the derivative of second function, again I need to apply the product rule. And sometimes what happens, in place of 3 functions, we are provided with the 4 or maybe 5 functions. So in order to avoid such a long calculation, what I advise you, you can take log both sides. Taking log both sides, what you will get? log of y, log of cos x, cos 2x and cos 3x. Now if you remember, I told you just now, log of a into b will become log a plus log b. Hence, it will come out to be as log of cos x, log of cos 2x and log of cos 3x. So that if you find the derivative of this one, you can find separately. There is no product rule applicable now. Differentiating both sides with respect to x, it will become 1 upon y dy upon dx. Log of cos x is 1 upon cos x and derivative of cos x will become minus sin x. Now come here, it will become 1 upon cos of 2x, derivative of cos 2x will become minus sin 2x and further derivative of 2x is into 2. Third one, 1 upon cos of 3x, derivative of cos of 3x is minus 3x, minus sin 3x and further derivative of 3x is into 3. Hence you will say dy upon dx, this y will be shifted there, it will become y into minus sin x upon cos x minus 2 sin 2x upon cos 2x minus 3 sin 3x upon cos 3x. You may leave till here or you can change this sin upon cos as tan. Then it will become minus tan x, minus tan 2x and minus tan 3x. That's our question number 1 of your exercise 5.5. Similarly, there's question number 2. I'll just give you the hint for the same. It's given x minus 1, x minus 2, x minus 3, x minus 4 and x minus 5. When you will take log on both sides, you know one thing, this under root, it will become power 1 by 2. This 1 by 2 will come down here in the next step and this log will be of the form log of a upon b. Then you will apply of log a minus log b. Again log a will be this one. Here also you will apply the formula for log a into b, which will be log a plus log b. Similarly here, and then you may find the derivative in very convenient way. Then I am going to explain one more question, because one question of this type is normally asked in the paper and which is very easy, but the common mistake which students do, I am going to share that mistake with you right now. You have to differentiate this with respect to x. Now sometimes students, what they do, they are just taking the log here. They take log directly here and then start solving. If you remember, I told you the property for log of AB, log of A upon B. But I didn't tell you any property where it is log of A minus B is given. It's not there. Fine. So that means we cannot apply log directly here. Whenever there is a function given to you which is in the form of variable ki power variable, 2 or 3 functions are provided and in between there are signs of plus and minus, you are going to choose each function as a separate one, right? So what we are going to do, let u is equal to x raised to power x and v is equal to 2 raised to power sine x. Fine. Now you may draw a line in between or you may solve it side by side or separately. U is equal to x raised to power x, taking log on both sides. You will get it as log of u, log of x raised to power x. It will become log of u x into log x. Now you will say differentiating both sides with respect to x. It will become 1 upon u du upon dx, x into derivative of log x, because there is in between dots, so there's a product rule is applicable. 1 upon x plus log x into derivative of x is 1. It will get cancelled. So du upon dx will become u. Here it is 1 left and here it is log x. 1 plus log x and value of u was taken as x raised to power x into 1 plus log x. This is du upon dx. Now come here. This will be V. So taking log on both sides, you will get it as log of V log of 2 raised to power sin x. Log of V, it is sin x into log 2. Differentiating both sides with respect to x, you will get 1 upon V. Derivative of log V is 1 upon V. Since you are differentiating with respect to x, so that means it will become dv upon dx. Derivative of sin x as it is, I am writing sin x as it is. Derivative of log 2 will become 0. Then log 2 is there, and derivative of sin x will become cos x. Fine. So dv upon dx will become v into cos x into log 2. But v was taken as 2 raised to power sin x. It is cos x into log 2. Now what we have to do? We started from here. So that means you have assumed y as u minus v. dy upon dx will become du upon dx minus dv upon dx. So this du upon dx and this is dv upon dx, which you will substitute here at both places to get the value of dy upon dx. So your entire exercise 5.5 is based on the same 5.5 and 5.4. that these two exercises you have to complete today, and if any doubt is there you can ask. Now this is the work which I am assigning you till Saturday. Now on Monday I will be sending next video soon. Thank you and have a nice day.